Hey friends, my name is Steve Guttenberg. This is the Audiophiliac Daily Show. And today is a very special episode because my guest is none other than Nelson Pass from First Wat and Pass Labs. But it came together because I'm reviewing the First Wat F8, which is the newest First Wat. And I've reviewed others. I've reviewed the J2, the F7, the SIP3, and I still have them all here on hand, and I decided to do extensive listening tests between those four. And I thought, I should talk to Nelson about what were his goals for designing these amplifiers, because each one is its own thing. They're not just like refinements of each other. They're really new designs. And so we got into it. We had this great, very long conversation. I'm going to present it pretty much unedited. So it'll be in two parts. Both parts will run today. And of course, there'll be a review of the F8, which I will link to. So without any further ado, let's hear from Nelson.
Well, let's see. You wanted to actually talk about the progression represented by about, what, 4 or 5 amplifiers?
Right. J2, okay. F7, SIT3, and F8.
The J2, though, dates back to something earlier called the LFJ, right? And the LFJ dates back to the LF. Probably the closest would be the LF3.
Huh.
So these guys, like, they go back basically to like 91, 92.
Nice.
The attraction here is, amplifiers with almost no parts that work. I enjoy that, I mean, in the same way that Picasso could express something with a single pencil stroke, I like to be able to think in terms of, minimalism delivering the goods.
What I want to know is, and I think I've asked you this in various forms before, but it's still fascinating to me as a totally non-technical person, that when you sit down to design an amplifier or stand up, do you have like something in your head? I want it to be like this. I don't want to use, you have like a list of particulars. I don't want it to have feedback. I don't care about gain. I want to have fewer gain stages. Do you have like a recipe to start?
Well, my generalized recipe is I first off like simple. I like simple circuits, okay. And partly because I understand them much better. I can predict them a little more easily than complicated circuits. But in terms of when I set out, usually what I do is I find something interesting and I explore it. And more often than not, recently it has been the parts themselves, specifically the semiconductors or gain devices in general. So that they all have this unique personality, and if you spend a little time with them and you think about them a bit, they start telling you how they want to be used. And so some of that is it's kind of a collaboration between me and the part.
Feedback. Would you say feedback?
Pardon?
I was trying to make a joke. Feedback, so to speak.
Oh, well, it's just that, like, say you play with something and you go, wow, it really likes this. Now, the criteria for like usually is that the distortion is low to start with, and that the distortion is a particular character, which is, for me, the preferred one is second harmonic, and of that, I usually diddle with as to which phase that might be, but I prefer second, or I should say, the customers of mine tend to prefer minus phase second harmonic. And so I see to it that any design that I do would probably be capable of doing that in some way or other. So the thing is that all these parts, they have personalities of their own. They just have their own characteristic, and it's reasonably complex. It's often easier just to stick them into a simple circuit and see what happens. And when you talk about simple circuits, there's two basic varieties. One is a follower. One is something with voltage gain associated with it. For FETs, those are known as common drain, which is the follower, or common source, which is the one that has voltage and current gain. If those were tubes, we would say common plate, and the other one would be common cathode.
Okay.
The idea, the common word means which pin is being grounded effectively. So you know, I play with the parts and just kind of see what they're like. And they all have got a fairly complex set of curves, because you've got the transconductance curves of the device versus various current and current levels and bias voltages and so on. But the transconductance figure as at a fixed voltage across the part is one thing, but then that that characteristic is played off against what, if it were a tube, you would call the plate characteristic or the plate impedance. And again, a FET has the same kind of very similar characteristics, and bipolars have some analogous characteristics like that. So all these things come into play and they work against each other, and each one depends on the load, depends on the bias, depends on the bias current, the bias voltage, temperature. You know, there's a nice long list of things that all interact. And it is some nice, very complicated equations for that, which I don't care to solve. It's a lot easier. It's a lot more fun to plug the part in and see what we got. And when it starts looking good, that's when we start thinking about, you know, getting serious with it and putting it in a state where it can be listened to.
Okay. Oh,
and
how far down the road is it that you would actually build one to listen
to? Depends. It could be right away.
Okay.
As a concept.
Just
you know, if everything is coming together and it's all cooperating, you can carry it right over to the speakers and fire it up.
But are you surprised?
Usually there's some distance in time, because I like to map the territory as much as I can before I start committing to listen.
But are you surprised by what you hear?
Sometimes.
Can you predict it, in other words, based on the way it measures?
I've gotten so I pretty much can. You know, I've come to see a particular formula that always yields very similar sorts of results, and that's in the context of single-ended Class A, and you know what the harmonic content is. You know, how much second and third and higher order harmonics and so on and so forth. Also, the output impedance matters. It's certainly nice to have some gain. Gain. But once you kind of settle on that, there's still a whole bunch of ways of, you know, getting there. I focus on the fundamental conditions that where a single device is the dominant piece, and that's another aspect of the simplicity is that the product starts speaking pretty much with a single voice. If you have lots of different special effects on different parts and you have them all in series, usually it doesn't give you what you want. So that I will tend to surround what I think of as the dominant gain device, which could be a power transistor, but it could be an input transistor. It really depends on what you're doing. But the product largely takes on the voice of that piece and its characteristic. I find that that's just a lot simpler in terms of analyzing this and experiencing it. It's also a lot simpler in terms of consistently creating an experience that somebody else is going to perceive the same way I do. Now, there's plenty of examples where you have a complex product and a lot of stuff is going on and everybody still loves it anyways. That is a very difficult result, I think, to achieve, and I suspect that much of the time it's by accident.
But the thing is, you've said, and we've had discussions about this, that the first one amplifiers have personality. In predicting that an F7 is going to sound great with a certain speaker, that's harder to pin down, right? It's like you really got to try it to know. That's fair.
It is. Well, you know, the F7 has a voice that is different than most of the other first watt amplifiers. Um, and it harkens back to an age where I was interested in uh, achieving with great simplicity, nevertheless, very low distortion and some other great specs, but doing so in a manner where there's very little circuitry there, and yet from a measurement standpoint, it does extremely well.
Right.
F7 is a fine example of that.
Right.
Pardon?
When I reviewed the F7, you pointed out that it had no degeneration.
It does not have any degeneration, although it uses lateral power MOSFETs for its output. In fact, it's really only a pair of input JFETs and a pair of output MOSFETs, but the output MOSFETs are laterals. They're attractive because you can operate them undegenerated because their temperature coefficient is very low, so that they don't drift much with temperature. But at the same time, the gain on them is quite low, and so you can't develop a lot of gain there. You don't really have much opportunity for putting feedback in the circuit and getting some of the numbers that you might be looking for. And when you're talking about a neutral piece, one whose harmonic content is low, but it isn't, say, dominated by second. In fact, the F7 is a third harmonic creature. It has symmetry plus to minus, as have many of the past efforts. The X amplifiers, the early ones, were all completely symmetric as much as we could make them. And so they had what I would call a third harmonic character. That's different than the first Watt stuff initially. And it's different from what we're currently doing in past Labs product, which we give it a, we actually allow the natural asymmetry of the parts, which they always have some. We don't worry about suppressing that or compensating it out. So that it's got a little second harmonic and then a declining amount of higher order harmonic. So it's got some second, it's got some third, but it's mostly second. When you go back to early past Labs product, the X series specifically, and this was after the Alephes, that's a third harmonic piece. And sometimes we just, we go both ways. So when you follow the progression of what the company's products are, there is a progression to this. And in many cases, it started out with one kind of sonic signature and ended up, years later with something that's quite a bit different.
Yeah, but in the four that I'm doing, J2, F7, SIP3, and F8, I can't see like a progression towards a sound.
Well, not with the F7 in there, because the F7 is a third harmonic creature.
Okay.
It is an effort to take an extremely simple circuit and get very good, really measured performance, and also what I would consider to be a very neutral sort of performance. So it sounds good, but it isn't exciting. It doesn't make you jump up and down. And it derives some of its performance through obscure tricks that were forgotten 50 years ago.
Wow, like what?
Yeah. Well, the positive current feedback dates back to the 50s, when Paul Klipsch and the boys were going, oh, well, here's a great idea. We'll put some positive current feedback on our tube amps and we can have a damping factor. How about that? But it appeals to a slightly different taste.
And it's also less expensive. I hate to bring up money. Less expensive than all the other. It's $3,000, I think.
Well, at this late date, the parts in it, they didn't used to be exotic, but they are now.
Oh, okay. So now it's
because it's running the Toshiba JFETs on the inputs, and these are lateral MOSFETs that have were made as complements for audio for all intents and purposes, and they went out of production. There's some other replacements out there, but if you actually want the originals, I don't think you can get them anymore. So it's another case of me having a nice stash of things that you can't get anymore, stick them in a product.
There you go.
It cuts down on the copycats.
That's important.
But the F7 is a different, it's kind of like sitting outside that lineup, because all the other ones have got a large degree of single-ended Class A to them, or are purely single-ended Class A outright, and as such they have they've got a second harmonic content that isn't present in the F7, and wasn't present particularly in the F5, which was the F7's predecessor. So there's almost two lines of development going here.
Well, but in many ways, the J2 seems like, that's where it started for me. And actually living with these amplifiers has been, I sort of just change them out by mood, or that day or that week or something, right? But as I listened to the four of them, the J2 seemed more like the most normal, like a really good amplifier. And the others, to me, had more personality, especially the SIT3. The SIT3 was more Koetsu-like, it was more va-va-voom kind of sound.
Well, there was something different about each one.
Yeah, I'd say.
For First Watt, that's kind of the point. For every amplifier that's been actually produced by First Watt, there's 4 or 5 others that sit on the shelf. All sorts of great stuff. The def amps, the deficits, the deficit. Nobody's ever seen that. It's spectacular. But I had to choose between it and the SIT3. Partly because the SIT3 is buildable. And some of these effects are only achieved by intense matching and screwing around, and then you finally get it just right. You go, wow, isn't that amazing? For me, of course, isn't that amazing might often be, well, it sounds as good, but it has like this many fewer parts in it. And sometimes, though, what it takes to get those fewer parts to do it is beyond the pale. So the SIT3 is related to the deficit, is related to the def amp, and these things all kind of like, float back to some source.
Is there a museum?
They're all a little different.
Do you have some version of a museum of all of them in some sort of, okay.
Yes, I do.
Good. Well, maybe I'll come back.
I have inventory. I have spreadsheets of inventory of these things.
Okay.
I can keep track of what I've got. It's sitting. I have it. I mentioned before. I got a new storage space also, additional. So that I'm waiting. I'm actually waiting for them to deliver shelving so they can start putting more stuff in there. But I'm looking forward to being able to walk around in my shop. I told you before, at this particular moment, if I want to get to many things, I have to open the big garage doors, which, the power opener, and then go around out the other door and come around the other side, which if it's raining is really...
You're a hoarder.
Yeah. Yes, no, because everything I've got has huge value.
Okay.
That's the distinction. There's no old copies of magazines and stuff laying around here. That's not what we're talking about. Yeah, partly because I still have a very nice batch of the semi-south, those silicon carbide parts. Now the J2 uses the part that's known as the R100, which is a power JFET, but it is an enhancement mode device as opposed to a depletion mode. Depletion mode devices are like tubes. You got to apply voltage to them to shut them off, and a depletion mode transistor is one that naturally says, yeah, sure, come on through, and the electrons just flow until you apply opposing voltages on the gate so as to shut it down. So tubes are like that, and in the case of FETs, they come in the 2 flavors of enhancement mode and depletion mode. Depletion mode is a real interesting one. The SITs are all depletion mode parts, or at least all the ones I've played with so far. And as are things like those nice Toshiba JFETs I play with. But the R100s were interesting that were silicon carbide junction FETs, but they are enhancement mode. You have to apply a positive voltage to the gate relative to the source pin, and now it starts conducting current. And that gate voltage is about a volt or so. It's not very much. The depletion mode part, equivalent of that, is called an RO85, and it is you got to put 3-4 negative volts on the gate to control that. So it acts like an SIT, except that the drain impedance is higher, and that makes it useful for some different sorts of amplifiers. One of which would be, well, first off, you could build some very simple Class A amplifiers where almost no control voltages or anything. It would just be you could actually get it down to just those two semiconductors, one on top and one on the bottom, and nothing else. In fact, actually, you can get it down to one semiconductor quite easily. They make good current source amps, which is a category. I mean, they make nice voltage source amplifiers also, but current sources are interesting in that there's ongoing interest in current source amplifiers, and I've dealt with that in the past, and there's groups of people who get all excited about that and play with it for a while, and then it just kind of fades off. The latest bunch of people who seem excited about current source amplifiers are people with compression drivers who are driving mid and top ends on horn-loaded systems. I don't know quite the merits of that at this point. I only know that they're excited about being able to build some of these amps up. I'm going, well, these semi-south RO85s are like made to order for this. You can slap an amp together with almost no parts and it'll perform very well. And
what does it sound like?
Well, that'll depend. It depends on a whole bunch of stuff, not the least of which are the bias points that we pick and how we arrange, say, the loading on that part, and whether we're using it as a voltage gain device or whether we're using it as just a current gain device. So there's a matrix of instantaneous possibilities. I haven't started working with it yet. I just started thinking about doing that, and I stuck it on my to-do list.
But this is part of the whole F2, F3.
Well, the F1 and the F2 are current source amps.
Okay.
And they kind of followed conceptually what I was just discussing, except that the depletion mode SiC parts, silicon carbide, they are even easier to do that. They the attraction here is, amplifiers with almost no parts that work.
So I said to you, I think in that call, that using the SIT3 on the clipped Cornwall 4s, I was listening to this group, African Head Charge, and it's kind of like ambient. They're not African, but it's like these very deep beats, and it's kind of ambient and stuff. But the low bass parts of it were so intense over the Cornwalls, more than the F8, more than the J2, more than the F7. It just had this really solid punch. That's what I mean by being kind of Koetsu light. It was like Technicolor. It was lit up with that amplifier. So,
well, the SIT3 interacts more with the impedances of speakers. In other words, it's more dependent on the characteristics of the speakers than the other amplifiers. So that in all probability, the other amplifiers are more neutral. And in this case, there could be an impedance bump or dip that alters the characteristic of that second harmonic in terms of its amplitude and phase relative to everything else. So the something like an F7 doesn't allow the personality of the speaker to interfere very much. I mean, a lot of amplifiers and the classic notion of what a audio power amplifier ought to be is, it doesn't matter what the load is. Right. It's going to be just, it's going to have this output voltage, and it's going to have that characteristic, that set of harmonics that will be associated with it as distortion, and their time relationship to everything else, and their relationships to each other are all, kind of a subtle thing that leave you the listener with some kind of internal impression after it's been decoded by your neural networks.
So
And
that's what basically. Wait, that's what the difference between one amplifier and another is.
well, yeah, I mean, in other words, obviously, if you have two perfect amplifiers, they'll sound the same.
Right.
Okay, and once you've achieved perfection, well, then you just buy whatever has enough power, and you're done.
Right. Exactly. That's boring. That's boring. I want.
Well, no, and it's the it's McLuhan all over again. He said that we take our obsolete technologies and we turn them into art. In this case, that's where this is from my standpoint. This is entertainment, both for me and the customer.
Mm-hmm.
I was telling you, I think on the phone that Mike Rothacker sent me. He's one of my buddies, and
right.
he's like he's one of those people who's smarter than I am, so it's great. And but he put together a little amplifier with a MOSFET and a little 6N6 little tube, running it off a glorified wall wart, big heat sink, 5 watts.
Okay. Is it a product? Is it real?
No, it's a DIY.
Oh.
I think he might like to turn it into a product. That sounds like a possibility.
Okay. Well, when he
doesn't step on my toes, that's not a problem.
Okay.
But just as likely to end up being we should probably, he's going to make some more. I can tell he's so thrilled to death by this, and I would say with good reason, because it's just a nice, sweet sounding amp, and it looks beautiful. It's a wonderful construction. So we should see to it that you get a pair and you can play with them, and they've got that signature, largely the tube.
Oh, so change the tube, change the sound.
Yeah, yeah, sure. I mean, it'll be one. It's kind of the same thing, but it'll still be a different blend. And the thing about the other nice thing about these is that you can alter the bias just a little bit one way or the other, and you have a slightly different sound. You can. I mean, the SIT1 demonstrated that that's actually a very nice effect to have. It's a nice knob to have. I don't tend to do it all that much because it makes our adjustment factor a lot more complicated. But in the SIT1, there was a meter and a knob, and you could turn it up and you could turn it down. And as you turned it up, it got to be lower and lower distortion in terms of that second harmonic. And at one point, it actually nulls the second out, so as all that's left is third. And then if you go beyond that, now you have a positive phase second, so you can actually sit there and play with this. And in fact, allowing people to play with it is what pretty much set the standard for where we put the 0 point, the middle point on the meter. So that when you dial it up so that the meter is at 12 o'clock, which is the bias setting, that's the one that everybody loves so much, which was defined as 1% second harmonic at 1 watt.
And that's what's in the SIT3?
No, the SIT3 it's been set, and it would be a lot more difficult to set to alter, I think.
Okay.
Partly because it would just cut into the power spec heavily to do it.
Okay.
It's a different creature.